So here we have introduction to probability. Introduction. So when it comes to probability, we're interested in finding the percentage or the probability of some events. Is this happening? It's not happening. What are the chances? What are the odds? Well, probability is actually a function. How do we define that function? First, we need a set, a large set, that we call it the sample space. The probability of an event. Suppose we have an event, we denote that event by E, is defined as probability of event E equals to the occurrence or frequency of that event that we denote by N of E divided by the frequency of all the possible outcomes, which is denoted by N of S. S is called the sample space. S is called the sample space. Let us go over one example to feel more comfortable about these definitions. Example. We have a 6-sided dice. Suppose the question says, what is the probability of getting 3? Okay, perfect. So we have a six-sided dice, and we're interested in finding the probability of this event. So our event, or E, is equal to a set including 3. But when we just looking at our experiment, we might have 1 or 2 or 3 or 4, 5 or 6. All outcomes form the sample space. Sample space is the collection of all possible outcomes. This is denoted by S, which is equal to the collection, the set of all possible outcomes. Well, what are the possible outcomes? This can be 1 or 2 or 3 or 4 or 5 or 6. Okay. What is the probability of this event? Event E is equal to, we're following the formula to form a fraction. What's the frequency, or what's the cardinality of event E? The cardinality of event E, or the frequency of event E, is just 1. Cardinality of E divided by cardinality of S, which is 1 divided by 6. Now suppose you have a pair of dice. Now we have a pair of dice. What is the probability of having, for example, of having 11? So we have a pair of dice. Well, the probability of this event is equal to cardinality of the set of that event divided by the cardinality of S. What is S? What is E? Well, we have a pair of dice, two of them. So S, or the sample space, is equal to, you have two of them. You have 36 different choices. 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, and 1 and 6. The first one might be 2. 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, and 2 and 6. The first one might be 3. 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, and 3 and 6. The first one might be 4. 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6. The first one might be 5. 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, and finally 5 and 6. And eventually, the first one might be 6. 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. As you can see, by adding another dice, we get a huge sample space. The cardinality of your sample space is equal to 36. What is the cardinality of event E? The sum is equal to 11. Well, 11, okay, what are those numbers that actually give you 11? 5 and 6, 6 and 5. So E has only two members. 5 and 6, 6 and 5. The cardinality of E is equal to 2. So we get 1 over 18. This is the probability of this event. Awesome. And here. Let M and N be two integers such that M is less than or equals to N. There are M and minus M plus 1 integers in between M and N inclusive. So the question says, how many 3-digit integers are divisible by 5. How many integers, 3-digit integers, are there and are all divisible by 5? Okay, so they have 100, 101, 102, 103, 104, 105, 106, the rest of the numbers. Then we have 998, 999, 997, 996, 995. So they're all digits in between them. So this guy is actually 5 times 20. Okay, we can count the rest of them. 5 times 21, the rest of the digits. So this guy is 5 times 199. And then it stops here. It's not a multiple of 5. So we're just interested in these numbers because it says are divisible by 5. So our goal is to try to use this theorem that we just learned. The very first number is 20. So this guy is going to be your n. 199 is going to be your n. So using the theorem, we have 199 minus 20 plus 1, which gives you 100. See, 100. Between 100 to 999 divisible by 5.